So here we are given fx is equals to x squared. So when you differentiate, you're going to say this 2, then x, then 2 minus 1, then you're going to have 2x. So now let's see if you are integrating 2x. So if you're integrating 2x, you're going to say 2x, and then to the power of 1 plus 1, then over 1 plus 1. Then you say plus c. Then you're going to have 2x squared over 2. And then you notice that the 2 and the 2, they're going to cancel. Okay, sorry. 2 and 2, they're going to cancel. Okay, let me reload this page. Okay, the 2 and the 2, they're going to cancel. Okay, so the 2 and the 2, they're going to cancel. So you notice that we are going to have, so these 2 and 2, they're going to cancel. Then we'll end up having x squared plus c, which is the same as this x squared. That's why we say that integration is the reverse of differentiation. Okay, so now let's look at integration rules. So let's start with the power rule for integration. So the power rule says that if you are given x to the power of n as your function, when you integrate it, you're going to have, say, x to the power of n plus 1, then over n plus 1, then you say plus c. It's the same thing as what we did here. So let's see how it goes. So here they're saying integrate the following. So you're going to start with this a. So f of x is equals to x to the power of 3. So when we integrate, we're going to say the integral of x to the power of 3. Let me just use this for now. Dx. Sorry, x to the power of 3 dx. Okay. We are going to have, okay. All right. Okay, sorry about that. So this will be dx. We're integrating this, so the answer will be, it's going to be x to the power of 3 plus 1, then over 3 plus 1. So it's going to be 3 plus 1, then over 3 plus 1. That's how we integrate. Then don't forget to say plus c. That's what I did. It's the same as this. So we are going to have 3 plus 1, it's 4. So we're going to have x to the power of 4, then over 4, and then plus c. So that's how we integrate the first one. And then now we move on to the second one. So if we have 6, then x to the power of 5. So it's going to behave like when we're differentiating. So this will be, we're integrating 6x to the power of 5. So I'm just going to write 5 with the red so that you can see. Don't forget the dx. So this will be equals to, then this will be 6x to the power of, then we are going to say 5 plus 1. So we always add the 1. With differentiation, we say minus 1. So this one, it will be 5 plus 1, then 5 plus 1, then this is over. Don't forget to say plus c. And then this will be equals to, sorry, this will be equals to 6, sorry. So this will be 6. This is going to be 6. And then x to the power of 5 plus 1, it's 6. So we're going to have 6. Then 5 plus 1 is 6 to the power of 6. Then over 6. 5 plus 1 is 6. And then don't forget to say plus c. All right. So now it means that I'm going to rewrite this step because I want to show you. So we have 6, then x to the power of 6, then over 6. So the 6 and the 6 are going to cancel. I'm just doing this so that you can see. So these two are going to cancel. Then it means that my answer is x to the power of 6. Then my answer is going to be x to the power of 6. Don't forget the plus c and then plus c. Okay, and then we move on to now, let's see if we integrate the constant, what happens. So if you're integrating a number without the variable, so we're going to have integral of 5 with respect to the x is going to be equals to, okay, let me see if I didn't forget. Okay, yeah, so we're going to have, it's going to be 5, then over, so it's going to be 5, then x to the power of, it's going to be x to the power of 0, because we didn't have x, then you say plus 1, and then this will be 0 plus 1. And then don't forget to write the plus c, so we're going to have plus c, and then we're going to have 5, then x to the power of 1, x to the power of 1, because 0 plus 1 is 1, then this is over 1, don't forget the plus c, and then we know that 5x to the power of 1 over 1 is just 5x, so we're going to have 5x then plus c, so that's how we differentiate. All right, so someone else might ask, why are we saying x to the power of 0? It's because x to any number to the power of 0 is 1. It's because x to the power of 0 gives us 1. Right, so we are introducing this one here. That's why we are saying x to the power of 0, because it's not going to affect our sum in any way. So it's 0 plus 1. So we're going to say x to the power of 0 is 1. So that's what I introduced there. Because I always have to add 1, then you say the exponent plus 1. So this is 0 plus 1, then over 0 plus 1. Okay, so every time you integrate the constant, your answer will be 5x. If it's 2x, if it's 2, it's going to be 2x. If it's 3, it's going to be 3x plus c. All right, but the derivative of a constant is 0. So can you see that is the reverse? All right, now let's go to d. So with d, and now you notice that we have a lot of them now. It's like we have 3, 4 terms. So we're going to do the same thing. So we are going to say the integral of x to the power of 3, and then plus 3x squared, and then plus x, and then plus 1. We're integrating this with respect to dx. So we're going to do it one by one. So we're integrating one by one. It's what we've been doing all along. So we are going to say it's what we did before with the derivative. Okay, so we're going to integrate each and every one of them. So I'm just going to put them in brackets. So we are going to start with the first one. So it's going to be x to the power of, sorry. So it's going to be x to the power of 3 plus 1. Remember we said we're adding 1. So it's going to be 3 plus 1, then over 3 plus 1. So I'm just going to use brackets so that you can see. And then we say plus, plus, then we move on to the 3x squared. So we are going to say 3x to the power of 2 plus 1. So it's 2 plus 1, then over 2 plus 1. Okay. So I am going to use this bracket. And then it's a plus. And then you move on to this one of x. So it's going to be x to the power of, because there's always a 1 if there's no exponent. There's always a 1 there. So it's just going to be 1 plus 1 over 1 plus 1. Okay. And then now we move on to 1. So it's going to be plus. So with the 1, remember we say it's going to be 1. Then x to the power of 0 plus 1. If it's a constant, it's going to be x to the power of 0 plus 1, then over 0 plus 1. And then plus c, don't forget the plus c. And then we are going to have here, it's x to the power of 3 plus 1, it's 4. So we're going to have 4, then over 4. All right? 4x to the power of 4 over 4, then plus, plus, and this is 3x, and then 2 plus 1, it's 3. So we're going to have 3, then over 3. Okay, and then we have, sorry, okay, and then plus, and then we have x to the power of 1 plus 1, it's 2. So we are going to have 2, then over 2. Okay, and then now plus, then 0 plus 1 is 1. So we are going to have 1 over, so it's x to the power of 0 plus 1 is 1. So it's going to be x to the power of 1, then over 1. And then don't forget the plus c, so it's going to be plus c. Okay, and then now we are going to have x to the power of 4, then over 4, then plus 3, x to the power of 3, then over 3, then plus, I'm aware that I'm rewriting this because I want to cancel now. And then the 1 over 1, so it's 1 x to the power of 1 over 1, then plus c. Okay, and then now the 3 and the 3, when you divide 3 by 3 is 1, so they are going to cancel. So these two are going to cancel. And then also this one is like we're dividing a number by itself. So we are going to end up having x to the power of 4 over 4, then plus x to the power of 3, then plus, you can say 1 over, if you want, just say x to the power of 2 over 2, and then plus x to the power of 1, then plus c. You don't need to write the x to the power of 1, by the way. Okay. All right. And then now we move on to this one. So if you remember, when we are doing the derivative, we used to say that the derivative of ln x is going to be 1 over x. So because we are integrating, the integral of 1 over x is going to give you ln x, because we said that integration is the reverse of differentiation. So we are going to say the derivative of 1 over x with respect to x is going to be ln. So the answer will be ln absolute x and then plus c. Right. Why? Because if, let's say, we were to integrate, let's say you say, okay, fine, I'm going to take this x to the top and it becomes x to the power of -1, and you derive this. What's going to happen is that, remember we said it's going to be x to the power of -1 plus 1, then over -1 plus 1. And this will give you x to the power of 0 over 0. The over 0 here, it tells us that this sum is undefined. It gives you a math error. You cannot divide a number by 0. So that's why we use the ln x. All right, so this is undefined. So that's why we use the ln x. Okay, I hope that makes sense. Now we go to this one also with the e to the power of x. We said that when you differentiate e to the power of x, is going to be e to the power of x. So the same thing applies with the integration. If you do that, it's not going to change. The fact that it didn't change when we were differentiating, it's also not going to change when we integrate. So we're going to have the derivative, so the integration of e to the power of x, sorry, the x is going to be equals to e to the power of x, then plus c. Don't forget, we always have to say plus c. All right. And then now let's move on to f of x is equals to this. Okay. So with the square root, I did this so that you can remember. And in case you forgot or you're struggling with maths, I'm trying to make it easy for you. I hope this will help. So I'm saying, remember this. Remember that the square root, it means that it's x to the power of 1 over 2. And then I said that with this one, if you have 1 over x to the power of 2, you're going to change it to be x to the power of -2, because when we are doing integration and when we are doing differentiation, we must always have an exponent and the base. It must always be x to the power of something. It cannot be 1 over. All right. So now let's look at this one. So the first thing we're going to do is first change our function to have exponents and. So our function is going to be f of x is equals to 2x to the power of 3, then plus, then we change this to be, so it's going to be x to the power of 1 over 2, and then minus, and in this one of the fraction, we are going to change it, and it's going to be x to the power of negative 2, x to the power of negative 2, and then now when it's like this, now we can integrate. So the integral of 2x to the power of 3 minus x, plus x to the power of 1 over 2 minus x to the power of 2, and then dx. So I'm going to write my answer here because I don't have a space. So I'm going to integrate this one first. I'm going to use brackets. So this will be 2x to the power of 3 plus 1. I'm just going to do this for now so that you understand. And then over 3 plus 1. Okay. Okay, then I close bracket, then I say plus, I'm going to move to x to the power of 1 over 2. So it's going to be x to the power of 1 over 2 plus 1. 1 over 2 plus 1, then over 1 over 2 plus 1. And then 1 over 2 plus 1, okay? And then this is minus, then we move on to x squared. So it's going to be x to the power of 2 plus 1, always. And then over 2 plus 1. Oh, it's negative 2, sorry, it's negative 2. I made a mistake, sorry. It's negative 2. Okay, yeah, it's negative 2. Then it's negative 2 plus 1. Forgive me. Okay. All right, then don't forget the plus. Okay, now we can solve. So we are going to have 2x to the power of 4 over 4. X to the power of 4 over 4 because 3 plus 1 is 4. And then we say plus, then this will be x to the power of 1 over 2 plus 1 is 1.5, which is 3 over 2. So this will be 3 over 2, then over 3 over 2. And then we say minus, this one is going to be x to the power of negative 2 plus 1. You can use your calculator, you're going to get negative 1. And this one is negative 1. Okay. Let me put this inside the bracket because of this negative 1. And then this is plus c. All right. And then now I am going to simplify this. So please note that 1 over 3 over 2, it's going to give you 2 over 3. Please note that, just in case you ask, where did I get that? Okay, so I'm going to have 2 divided by 2 is, 2 divided by 4 is going to be 1 over 2, and this is x to the power of 4. Let me write it here. It's at the top or next to 1. It's up to you where you write it. Then this is plus. This will be 2 over 3, x to the power of 3 over 2. Even if you write at the top, it's still correct. And then this is minus, and minus gives us a plus. So this is going to change. It's going to be a plus. Plus, okay, let me write these changes with the pen. So this is 2 over 3, in case you're wondering what happened. This is where we found the change. Then this will be a plus. Then it's going to be a x to the power of negative 1. Then it's plus c. And then now the negative 1 is going to change. So this will be 1 over 2, x to the power of 4, then plus 2 over 3. Then x to the power of 3 over 2. And then this is plus. Then now this x to the power of negative 1 is going to be 1 over x. And then this is plus c. Okay, yeah, so that's how we do it. Okay, I know it's long, but with practice it will be fine. Okay, let me rewrite my x so that it looks fine. Okay, so this is x. Okay. Okay, let me write something here also so that I can clear the air. Okay, so you please understand that 1 over 2 x to the power of 4 is the same as 1 x to the power of 4 over 2. Okay, please note that, so that in case you wonder. So please put it, it's either you put it next to 1 over 2 or you put it at the top, but it's the same thing. All right, and then now we move on to integration by substitution. So they're saying that integration by substitution will reverse the chain rule differentiation. So if you can remember the chain rule differentiation we had where we say let u be u equals to something. Okay, so when we integrate, we set u. So this is the composite function. I think we spoke about the function of a function. Okay, so when we integrate this one, we are firstly going to start with saying we set u. We start by we set u to be 4. Oh, sorry. We set u to be, okay, sorry about that. We set u to be 4x plus 3. Okay, so after we set u equals to big, and then we differentiate. Then we differentiate after this. After we set this, we are going to differentiate. So we are going to say the derivative of u. Then, okay, let me just say then. We say the derivative of u with respect to x is equals to, okay, so we differentiate. So we are going to have, okay, so step number 1, let me write it as step number 1 so that you understand. So the first thing you do, you set this, so this is number 1, okay, and then number 2, okay, let me use another color. Hopefully it's going to help. If it doesn't help, I'll go back to the original color. Okay, so then I am going to say, so this is number 2. I'm going to say du over dx. Then I say it's equals to, when we derive this, it means that we are saying the derivative of a u. So u is 4x plus 3, okay, which is going to be equals to, remember when we derive, we say 4, then x to the power of 1 minus 1, then plus 0. When we derive, remember, it's 1 minus 1, the derivative. Okay, I'm just using this so that you remember. Okay, sorry. Okay, I want to erase this one. Okay, so this will be 1 minus 1, if you remember. And then we are going to have, sorry, so we are going to have, our answer will be 4x to the power of 0, which is equals to 4. Why? Because x to the power of 0 is 1, if you remember. Okay, any number to the power of 0 is 1. Okay, just gonna write this here. Okay, so now we have our derivative. Okay, and then now, so it means that we have du over dx is equals to 4. So from this, we are going to change it. All right, we're going to, what is it? We're going to swap these two. So therefore, please note that we do this. You are allowed to swap 4 and x. So therefore, I am going to have, so I'm just going to do it here, du over, I'm just going to use a different color so that you can see that's what changed. This will be 4, and then the dx will be this side. You just swap. Okay, you're allowed to swap in mathematics, please. So here we swap. You're allowed to do the swap. And just say swap. Okay, you're allowed to swap. If it's a fraction, you're allowed to swap. Okay, so that's what we have. So that's step number 1, step number 2. And then after that, now we are going to start with our integration. Okay. Okay, let me just do this for space. I need space. Okay. All right. So now after this, so when I do it again, you'll understand. After this, now we swap. Okay. So I'm going to have, I swapped now, right? So step number 3, now I'm going to start solving. Okay. Just use a black one. Okay, now we're starting. So step number 3, now we're going to start. The integral of our f of x, all right? Our f of x, which is the integral of our f of x is what? It's 4x plus 3 then to the power of 3 dx. It's going to be, we're going to have, now we're going to substitute. All right. We said 4x plus 3 is u. Okay. We're going to substitute this, right? We start with this one. So this will be u to the power of 3 because we said that, all right. And then now dx, which is this one. Dx is what? Is du over 4. So that's what we're going to do. We are going to substitute. I'm going to use blue. So this will be a du over 4. All right. So now from here, please, okay, let me just write here what we do. We substitute. I'm just going to write it here. From here, we substitute. Substitute 4x plus 3 with u to the power of 3. And then we substituted dx with du over 4. Okay, just in case you don't, that's what we did here. That's what we did here. Okay, then from here now, you're allowed to do this. So now we are going to, every time, you're going to take this 4, this side is going to be 1 over 4. Ne? It's not jumping equal sign. So you're going to have 1 over 4. Then you say integral. Then what's left is u to the power of 3. And then also du. Then now we derive. So when you integrate, sorry. So when you integrate this, remember we said that it's going to be what? U to the power of 3 plus 1 over 3 plus 1. Don't forget. 3 plus 1 over 3 plus 1. That's how you integrate. And then you say plus c. Don't forget. And then we are going to say 1 over, then it's u to the power of 4. Right? Then over 4. Okay? So this is 4, then 4 over 4. This is times, no? Sorry. This is a multiplication, it's a bracket. So this will be bracket. So it's u to the power of 4 over 4. U to the power of 4, then over 4. And then don't forget the plus c. So this is plus c. This is plus c. And then we are going to have, sorry, I know it's long, so I made it long on purpose so that we understand. But as time goes on, I think it will make sense. Okay. And then after this, we are going to say this will be 1 times, so you're just going to have u to the power of 4 over 4 times 4 is 16. And then now we are going to have, we said that our u is, so we're going to substitute back. So we're going to replace u with, so our u is 4x plus 3, and then to the power of 4, sorry, to the power of 4, yeah, not to the power of 3. Add to the power of 4, and then over 16, because 4 times 4 is 16, yes, so over 16. So that's how we integrate with the chain rule. Okay, let me try again. I'm going to do it again. Okay, so this is it's a composite function. So obviously we're going to change the 2x minus 1 to be u. So that's what we're going to do here. So I'm going to try and do it and make it short. So u here, it's going to be 2x minus 4. And then we said that after this, we must differentiate. All right. And then this one will be, just going to make it very, very fast. So this one we are going to, what is it? Differentiate. So when you differentiate, so we're just going to say the derivative of, with respect to x, of 2x, 2x minus 1. We are going to have, the answer will be, okay, let me do it this way, because if I do it that way, the answer will be 2. Okay, because remember, you're going to say 1 minus 1 is 0, and then, yeah, so the answer is just 2. Okay, and then I said that you swap. So when we swap, we're going to have du over 2. Okay, du over 2, then is equals to the x. You just swap. Okay, you just swap. So this one we swap. Please don't forget, you can swap. You're allowed to swap if it's a fraction on the other side. Okay, then now we're done. So we have that. So now we're going to continue. Okay, let me just do this. So this is 2, and then du dx. I don't want to use a red pen, just want to consistency. Okay, fine. So after we get that, then now we move, we integrate. So we're going to do the integration. So the integration, so this is step number 1. Okay, I'm just making it shorter now so that you can see. So step number 1, step number 2. Okay, step number 2, and then now we're going to do step number 3. Okay, step number 3, we integrate. So the integral of the original function, which is 10 over 2x minus 1, okay, with respect to x, okay, so this will be equals to, and now we're going to change it. Remember, we said that 2x minus 1 is u, so I'm just going to say this is 10 over, we said our u is 2x minus 1, so it means that I am going to have over u, and then we said that dx is du over 2, so we're just going to say that. So, and then this is times, let me just put a bracket du over 2, okay, and then yeah, that's it. And then now we move. Okay, so remember we have to change, we have to take what do we have? Okay, so we have this times this, so we're going to multiply, sorry. So we multiply, we can take this 2 to the other side and also take 10 to the other side, because I want only u to be left alone. So I'm going to have 10 over 2, and then I just say this, then I'm left with 1 over u. It's up to you how you want to do it, okay? Then you're left with the u. The aim is to have only u alone. Okay, so I move this number, I move this 2 because it's already at the bottom. I put it this side, then I move the 10, so it's a fraction. Okay, so 10 divided by 2, it's 5, so I'm going to have 5. And then now I have bracket because I have to solve the 1 over u. So 1 over u, it's going to be, remember we said when we integrate this, is going to be ln. So this will be ln x. Okay, so it's going to be ln, not ln x, ln u. Okay, ln u, and then plus c. Why is it ln u plus c? It's because there's going to be ln u. Okay, let me just do this. It's going to be ln u plus c, because we said that ln x is going to change and become, not ln x, 1 over x is going to change and become ln x. So I can say 1 over u changes and becomes ln u when we integrate. Okay, and then now we want to change back our u. So our u, we said it's 2x minus 1. So it means, therefore, I'm going to have 5. And then I will have ln. And then now I'm changing my u. My u is going to be 2x minus 1. Then plus c. Then we're done. Then plus c. So with practice, it will make sense. Okay, let's do it again. So we're going to do it again. Okay. We have a function this. Okay. So when you're seeing this, remember we said that. We said the integral. Don't forget. So I think I should write it here so that you remember. When you see this, don't forget that we said that the integral of e to the power of x dx is equals to e to the power of x plus c. Please don't forget that. So let's see. So here I am going to start with u. So obviously 5x minus 2 is your u. Remember chain rule, okay? Composite function. So u will be 5x minus 2. That's step number 1. Step number 2, you differentiate. Step number 2, differentiate. Step number 2, I am going to say the derivative of u with respect to x, which is the derivative of this, is going to be 5 because this one gives me 0. By now you should know. So this will be 5. And then if this is 5, then it means that now we solve. Therefore, 5 and dx change places. So we're going to have du over 5 is equals to dx. I am going to write it here and say we swap. That's it. It will always work. No? Don't think that it's not going to work. It's always going to work. Okay. Then now I have my dx. So now I can go to step number 3 of integrating. So step number 3, I'm going to integrate the integral of my original function, which is e to the power of 5, x minus 2, dx is going to be, okay, now we change. We said that 5x minus 2 is u, so this will be integral of e to the power of u, and then we said dx must be du over 5. So the x changes becomes du over 5. Okay, let me just use a bracket. It's fine. Okay, so now we continue. It means that I'm going to take the 5. That's going to be 1 over 5. Because I only want a function with the u. So this will be 1 over 5 because the 5 is at the bottom. So there's a 1 there, which is here. So it's going to be 1 over 5. It's a fraction. It's 1 over 5. And the integral of, so it's going to be e to the power of u. Then don't forget du. It's already this side. Okay. Then now we can integrate. Okay. So now we're going to have 1 over 5. When we integrate e to the power of u, it stays the same. So we're just going to have e to the power of u and then with a plus c. Don't forget. Why? Because the integral of e to the power of x still stays the same. So it means the integral of e to the power of u stays the same. It becomes e to the power of u. And then now we are going to replace our u. So this will be e to the power of our u. We said it's 5x. So this will be 5x, then minus 2. Then don't forget the plus c. And then this is plus c. And then that's it. Some, they can write it and say this is e to the power of 5x minus 2, then over 5, then plus c. It's still fine. That's still correct, okay? So I hope you understand. If you don't understand, you can rewatch the video or you can ask questions on our next class. If there are any mistakes, we will fix them on our next class. Yes, I think that's it. Thank you. Let me stop the recording.